For today's lesson, we're going to be comparing temperatures. So throughout the week, we have been just looking at one set of data, and now we're going to be comparing two different sets of data. So this is the temperature in City A after a certain day between noon and midnight, and City B, same day, same times. It's just represented by this table. Now we need to understand which is warmer at 4 p.m., City A or City B. Well, what I can do is I know that my x-axis here is time in hours after noon. So what we're going to do is go over to the 4, and we're going to go straight up, just like what we've been doing the last few days, and put a dot. And if I go over, I can see it's about 57 degrees at 4 p.m. for City A. Now for City B, I'm going to do the same thing, and H is our x, so hours, and our temperature is y. So at the 4 p.m., it is 62 degrees. So which city was warmer? We're going to say City B, because it was 62 degrees versus 57. So what you're going to write is City B was warmer at 4 p.m. And now our second question says, which city had a bigger change in temperature between 1 and 5 p.m.? How we can know that is, we're going to take this box here of the times, of the temperatures. I know at 1 p.m. the other day we said it was about 50.5 degrees. And what I'm going to do is figure out at 5 p.m. how much that is. And it looks to be about 58 degrees. If you said 58.1, that is totally fine, however you want to phrase it, because it's different for everybody in their views. So what I'm going to do to find the difference or the big temperature change between 1 p.m. and 5 p.m. is I'm going to take 5 p.m., so the 58 degrees, and subtract it from the 50.5 degrees at 1 p.m. And what you're going to see here is that we're going to get 7.5 degree change. So for City A, there was a 7.5 degree change between those two times. Now for City B, I'm going to do the exact same thing. I'm going to take from 1 p.m. and I'm going to take 5 p.m. and see the change. So I know that at 5 p.m. it was 58 degrees, and I'm going to subtract it from 82 degrees. If you actually calculate this out, it's going to be negative 24 degree change. Now, this does have a negative change, but in math, usually we say that it's just a regular 24 degrees. I could have flipped it the other way and still got the same answer. So in this case, whether it's positive or negative, I know that City B has a big temperature change. So what we're going to say is City B had a bigger temperature change of 24 degrees. And you can say while City A only had a 7.5 degree change. So take a moment, make sure you get these notes down. Remember, they are in your summit and they are under your 6th checkpoint. I think it's called comparing temperatures. Let's move on to the next one here. More questions about this, these two cities. How much greater was the highest record temperature in City B than the highest record temperature in City A during this time? This part right here that says during this time, it's just talking about this certain day. It's not talking about compare the two different times on two different axes or anything like that. What it's asking is, what's the highest temperature in City B, which we can look here and see that 82 degrees is the highest. And if we go over to city A, we can just follow the line and see where it hits its highest point, which is going to be right there, which is going to be 59 degrees. So now what we're going to do is similar to the last one. I'm going to take 82 because I want to know the difference between them, how much greater it is, and I'm going to subtract it from my 59. Take a moment and see what answer you get. And you should have gotten 23 degrees. So that means City B was 23 degrees warmer than City A at its highest point. So we can say City B at its highest temperature. Oops. City B at its highest temperature was 23 degrees warmer than City A. So City B seems to be kicking butt throughout this project, or throughout this problem. So now we're going to look at compare the outputs. So y, outputs are always y, of the functions when the input, so when x equals 3. So I know that this is dealing with hours. So I know that we're dealing with 3 p.m. So what I'm going to do is go to my x-axis here for City A, go over to 3 p.m. and go straight up, and I'm gonna see about what it is. So I know it's between 54 and 55. So I'm gonna say City A had a temperature of 54.5 degrees Fahrenheit at 3 p.m. And we want to make sure we include that it was at 3 p.m. because the input is 3, and most of the time it won't tell you what the input is. In this case, it's hours, or I guess in a sense, the time afternoon, so 3 p.m. So City B, I can come over here and go, okay, at 3 p.m. it was 75 degrees. So we can say had a temperature of 75 degrees Fahrenheit at 3 p.m. So now we're going to compare the outputs of the functions, meaning I'm going to take the highest number, so City B, 75 minus 54.5. And I want you to take that, and if you subtract both of them, the answer that you're going to get is 20.5 degrees. So we can say, again, City B and City A had a difference of 20.5 degrees Fahrenheit at 3 p.m. And again, you can phrase it however you'd like. These are your notes. So now let's move on to the last one, comparing volume. And remember, at any time you can definitely pause these videos and be able to make sure you write it down. Alright, so now we're ready for comparing volume. And your last little part here on your notes should look like this. The volume V of a cube with edge s centimeters is given by this equation. So this is our cube equation. So throughout we're going to be using this formula for cube. And the volume of a sphere is shown on this graph. So I know a sphere, which would be like a baseball or something circular, is going to be this graph right here. So I know I'm going to actually label here. It says the radius, which is going to be the x-axis. We can see with this little r here. I'm going to label the axes so that way when I go to answer these questions, I can instantly know what it's talking about. So is the volume of the cube with edge length, which is matched up here, s equals 3, greater or less than the volume of the radius of 3 for the sphere? So what we're going to do over here is we're going to have Q, which is our volume, or our formula here. And this is an S. V equals S to the power of 3. We know that this S is actually 3, so we're going to plug it in. So now I have 3 cubed. So 3 cubed means I'm going to take 3 and multiply it by itself 3 times. That's what this exponent tells me. 3 times 3 is 9. 9 times 3 is 27. So I know the volume of my cube is going to be 27 centimeters cubed. Volume, we always have it cubed. So now let's look at the radius of 3 for our sphere and see if it's the same. So I'm going to go over here, I'm going to hit 3, and I'm actually going to go straight up and stop right there. And then you don't have to draw these lines going over, but sometimes it might help you. So I know it's between halfway through 100 and this check mark. Well, I know that this is 0 down here, so I know that these are counting by 25s. Based on what I know, if I took half of 50, that would be 25. So I know that this is counting by 25s. Oops. And so on and so forth. So I know that my answer for the sphere, the volume of the sphere, is between 100 and 125. I'm going to say that it's about 112.5. If I took 125 and cut it in half, I'd get 12.5. So the volume of our cube is 27 versus 125. Well, I definitely know that the volume of our cube is less than the volume of a sphere, because 27 is much smaller than 112. So now let's answer this last question. If a sphere has the same volume as the cube, so the cube volume is the same as the sphere, and the cube has an edge length of 5, we're going to estimate what the radius is of the sphere. So I know cube volume, we looked up here, is the edge length cubed. So meaning I'm going to take my 5 and cube it. So I have 5 times 5 times 5. 25 times 5 is going to give me 125 centimeters cubed. So now I know that that's the volume of my cube, and it says that it's the same as the sphere. So what I'm going to do now is I'm going to take what I know and go over to 125 centimeters cubed for the volume. Oops, let me zoom out a little bit. So what I'm going to do now is I'm going to take this number, 125, and I'm going to draw a line straight across, and I want to figure out what's going to be the radius. Because we know what the volume is, we just don't know what the radius is. So if I go straight down again, I don't know what this next dash is, but I know between 3 and 3.50 or 3.5 is 3.25. So I know that it's between 3 and 3.25. I'm going to say the radius of our sphere is approximately, well, it's about halfway, and we established that the last one, halfway through 25, was 12.5. So I'm going to say the radius is approximately 3.12 or 3.12, or you can say 3.15. Anything between those, just make sure it's not greater than 3.25. And that's your notes for today.